Nowadays, cameras are a very important part of our daily life. To be precise, people are obsessed with cameras. Today, the cameras can click pictures as well as shoot videos. Initially, in 1825, Joseph Nicephore Niepce used a sliding wooden box camera made by Charles and Vincent to take the first permanent camera image. Cameras have evolved from dark boxes to modern digital cameras and camera phones through several generations of photographic technology, silver plate photography, printing plates, dry plates, and film. But have you ever wondered how cameras are made? Watch the video ahead to find out. Hey guys, welcome back to the channel How's It Made? Before jumping into the video, if you're new here, please consider subscribing to our channel. Also, hit the bell icon to get notification whenever we upload a new video. That said, let's begin. History of camera. The history of camera imaging can be traced back to BC when a photographic cassette was the prototype of today's camera. A camera cassette is an optical device that uses a light beam passing through a small hole into a dark room to project an upside-down image of an object. The mechanism used by this device is almost the same as that of a pinhole camera. From the 16th century, the camera eventually developed into a device that integrated a lens, a camera obscura, and a mirror, whereas in 1839, the French Daguerre invented the silver version of the camera. About 30 years later, Maddox invented the dry plate in the UK. It was with these inventions that the era of hand-painted objects came to an end, and the era of cameras that use photosensitive materials to record images officially began. Film camera. More than 170 years after the advent of the camera, the photosensitive materials used to record the images have been constantly changing. The photosensitive material first used silver plates, then developed into wet plates and dry plates, and finally people invented film. In acknowledgement of this course, other experts developed various types of film cameras that can accept different sizes of film. In addition, half-frame cameras that double the number of frames per roll of the film have also entered the market. Film cameras are also called silver halide cameras. The most commonly used type of camera film is 135 film, which is the standard size film used to shoot movies. Reversal film, which can make colors more vivid, is also used to make slideshows. The development of electronic technology has promoted the popularization and miniaturization of cameras. Surprisingly, electronic technology was actually used in cameras very early, dating back to the emergence of electronically controlled automatic exposure meters in the 1950s. This innovative design freed photographers from the tedious process of adjusting shutter speed and aperture. Not only that, due to the addition of autofocus function and autoflash, cameras have gradually become popular among the general population. At the same time, IC replaced transistors used in electronic control circuits in the past, which has also accelerated the pace of miniaturization of cameras. The history of the development of camera autofocus cameras. Digital camera. The 1980s were the heyday of film cameras. Subsequently, the camera field entered a new development process. This is the invention of the digital still camera. The newly invented digital camera has won the favor of the public with its many convenient functions. It can only eliminate the DPE step, but also displays the captured images on the LCD display for users to view in real time. In the 20 years after the introduction of digital still cameras, their production and shipments have surpassed film cameras, occupying an important position in the camera industry. Differentiation between a film camera and a digital camera. The difference lies in the process of recording the captured images. The film used in silver halide cameras performs two functions at the same time, taking images and recording images. The image sensor of a digital camera performs these two functions separately. First, capture an image and then record the image in a semiconductor memory. In addition, film cameras record captured images as they are, while digital cameras perform sampling, continuously quantize changes in exposure before recording images. So it's possible to obtain highly stable and reproducible image data. CCD camera. The development of digital cameras was continued by the advent of CCD, or charge-coupled device image sensors, which enhance the photosensitive performance of photodiodes. CCDs are used in many cameras such as small microscope cameras, camera phones, small digital cameras, and large single-lens reflex cameras. The multiple functions provided by CCD not only meet the needs of various applications including astrophotography and security monitoring, but also can be used for autofocus and exposure control. In addition, the recently launched three-dimensional camera can also be equipped with a dual-lens CCD camera to capture realistic images that are almost the same as the objects recognized by the human eye. How is a camera design made? Camera design is a complicated task to undertake. Not to mention, all designs of any product start with product conceptualization and evaluation of potential markets. In addition, consumer demand for the proposed product plays an important role. Speaking of the designing process of a camera, it commences with a computer-aided design workstation. Here at the CAD workstation, the configuration and working principle of the product are drawn. The main work of the designer here is to choose the materials, mechanics, electronics, and other functions of the design and construction, not forgetting about the interfaces with lenses, flash units, and other accessories. However, computer designs are also tested through computer simulations. As a result, the design reviewed by the computer program will be checked against the initial concept and marketing and performance goals. The prototype has undergone a series of rigorous field and laboratory tests. Engineers use prototypes selected for manufacturing to prepare design details, specifications, and tool manufacturing and manufacturing processes. Many of these are directly adapted from CAD designs through computer-aided manufacturing systems. Any system or accessory that interacts with a new product requires additional design. By using CAD or CAM design methods, camera manufacturers can conceive new products and prepare them for shipment in about a year. The manufacturing process of a camera body and cover. Speaking about the camera body and back cover, are generally made of polycarbonate composite materials. The material contains no less than 10 to 20% glass fiber. This material is very durable, lightweight, shock-resistant, and able to withstand changes in humidity and temperature. Its main disadvantage is that it's not resistant to chemicals. Next, the polycarbonate is molded to very specific tolerances because the internal work of the camera must be precisely matched to work properly, and the strength of the chassis is used to prevent mechanical and electronic components from vibration and other shocks. As a result, after the camera body is formed and properly assembled, it becomes the frame to which other parts of the camera are connected. Shutter and film transport system of a camera. Now, the shutter assembly and film transport system are manufactured on a separate assembly line. Although the film transport system has electronic equipment to read the speed of the film, these parts are mainly mechanical parts, while the DX film codes are shown as silver bands on the film roll, which are detected by multiple contacts in the film chamber. Whereas the more high-level cameras have microchips, as these microchips can examine the data printed on the silver tape and modify the shutter speed, flash, and different camera actions. Likewise, all parts are precisely manufactured. The film magazine size must be accurate to 0.006 of an inch. However, the shutter functions like a curtain that can be opened and closed. It must operate accurately to expose the film for the correct length of time and coordinate with other operations such as flash. Speaking of the making of the shutter, it's made of different materials depending on the type of camera and the manufacturer. Viewfinder lens. The viewfinder lens is a special lens manufactured using the same method as the camera lens. The viewfinder is also made of optical glass, plastic, or glass-plastic combination. Besides the most modest viewfinders, all viewfinders contain crosshairs. These crosshairs illuminate the frame and additional data on the lens to improve the photographer composing the picture. The inline mirror has a special coating of color separation, up to 17 layers of coating that can be added to the mirror to correct and modify its reflection characteristics. Single-lens reflex or SLR cameras have a through-the-lens viewing function, also known as real-image viewfinders, because they allow the photographer to see what the lens sees. The SLR viewfinder utilizes a prism to direct the light from the lens to the photographer's sight. The prism is made of optical glass to meet precise requirements and make correct framing possible. LCD screen and electronic products. Advanced cameras in the most compact models include liquid crystal display screens, which provide photographers with information such as film speed, aperture, photography mode, including landscape, portrait, close-up, and other modes, number of photos taken, red eye, and the operation of the flash and other accessories, battery condition, and other data related to the operation of the camera. The integrated circuit is the camera subassembly that forms the electronic brain of the camera, and if any, a flash is also attached. You see, quality assurance and quality control practices are taken for granted by camera manufacturers. All departments from manufacturing to transportation have their own quality assurance procedures, and company-wide quality assurance is also supervised by a separate department or department. The Supervisory Quality Assurance Department uses statistical methods to monitor various aspects of product quality, such as camera functionality, performance, consistency, and accuracy. They also guide one assembly system into another assembly system and provide corrective actions when problems occur. That's it, guys. Let us know if you have found this video informative in the comment section below. Also, if you like this video, give it a thumbs up and share it with your friends. And don't forget to subscribe to our channel for more informative videos. See you in the next one.